Hello dear students, welcome back to my YouTube channel. Am I audible and visible to all of you? Am I audible and visible to all of you? Yes? One second. Am I audible and visible to all of you? Yes, I got my voice now. One second. Thank you, beta. Thank you. Okay. So yesterday I have given you two homework, right? Homework question answer 1. Okay. And for 2 it is 1:2, right? So let us just discuss firstly the. Okay, today is Hasana's birthday. Happy birthday, beta. Happy birthday. And it is a sort of a rare case, right? And a student is not celebrating a birthday. Instead of the celebration, the student is attending class. It is somehow a rare case, no? Okay. So once again, so the I will just start the lecture now. Okay. I guess yesterday I have given you two homework numericals. Two. First was a charge moving with velocity v. A charge moving with velocity v in x direction is subjected to a field of magnetic induction in negative x direction. That means a particle is going in this way, right? V plus I cap. Okay, and magnetic field is given in this direction, B minus I cap. As a result, the charge will, okay, is it remain unaffected? One part. Start moving in a circular path of YZ plane, okay, retard along x-axis, okay, moving along a helical path around x-axis. Look now, the numerical is all about the force. I guess we know the force now. Force is equals to, is it Q V B sine theta? Yes, sir. You can see the angle between V and B is 180 degree. Can I place here Q V B sine 180? And the value of sine 180 is 0. So therefore, my force is equals to 0. If no force, no effect on the speed, I can write remains unaffected. I can write here remains unaffected. Okay, done. Now next numerical. This one, ionized hydrogen atom. Look, if we are talking about the hydrogen atom, okay. Now second term is ionized hydrogen atom. Ionized hydrogen atom. An alpha particle. Done. With same momenta. Momenta means P. Same momenta. Done, sir. Enters perpendicularly to a constant magnetic field B. Okay, no issue. The ratio of their radii of their paths. Oh, Myohana Chukia, yes, you should soon. Okay, So basically, if we want to calculate the radius, no, we are having couple of formulas. I guess no, yesterday we discussed those formulas. These are mv by qb, one formula, which is equals to p by qb, second formula. Then 2me by qb, a third formula, and fourth one is 2mqv whole divided by qb, fourth formula. Now, if momenta word is given here, that simply indicates we need to take this one, no? This one. Okay, sir. You can see now R equals to P divided by QB. P is same, B is same. Done. That simply indicates radius is inversely proportional to the charge. Okay, sir. The radius of H, hydrogen, to a radius of alpha equals to charge of alpha to charge of hydrogen. What is charge of alpha? So 2 times charge of proton, and charge of hydrogen is charge of proton. Cancel out. So my answer is 2 divided by 1, or you can write 2 is to 1. Done? Okay. So now in today's class, we will start Lorentz force. Okay. Now I will write what we will be starting in this class, that is Lorentz force. Which one? Which one better? Okay. Look now, look here. Nothing is given in terms of velocity or masses. Okay. If nothing is given instead of these two things, no, but instead of mass and velocity, momenta is given. So we need to, okay. Now you are saying me that why we cannot use the first one? No? Look, we have to take that equation only in which something is given in the numericals. Okay. Sir, momenta is given. If momenta is given, how you will compare momenta with mv by qb? You can just transform mv into p, no? That is p is given to us, and b is also given to us, that it is r is inverse to q, no? Okay. Now let's start next topic, that is Lorentz force. Lorentz force. Okay. Suppose we are having a plate. Suppose this is my electric field. Look now, my electric field. This is my plate with positive charge on this side. One more plate with negative charge. I guess we will get a electric field from positive to negative. Yes, sir. It's my electric field. And now magnetic field is also present. Magnetic field is also present. Okay. We are discussing some sort of what is Lorentz force, right? Look, electric field is given, and this is magnetic field which is into the plane. Okay. Now we just projected a particle, a positive particle inside this particular configuration. We know that if this is my electric field, and here we are having a charged particle plus q. So the charged particle will experience a force in the direction of my electric field, that is F equals to Q times C. If it is negative charge, so it will experience a force in the opposite direction of my electric field. Done? Look now. So this charged particle is positive, so it will experience a force in the direction of electric field, that is this one, F. Now charged particle is going in this direction, velocity is here. and due to this magnetic field which is inside, take your right hand, velocity v cross b, na velocity is in x direction. Now curve your fingers towards what? Towards magnetic field which is inside. So thumb will be given direction of your magnetic field. So your magnetic field is here. Now you can see on this particular charged particle two forces are being acted, Fm and Fe. So now what is the net force? Net force experienced by your particle, that is electric force plus magnetic force plus magnetic force. So this net force is known as Lorentz force. This net force is known as Lorentz force. Done. This net force is known as Lorentz force. Am I lagging? 1 second. Sometimes. Done, beta? This was all about my Lorentz force, basics of my Lorentz force. If somebody will ask you, what is Lorentz force? Lorentz force means the net force experienced by the particle when the particle is present inside electric field and magnetic field region. Okay, easier, very easy, no? Look now, let us just talk about this one now. So my net force, that is F, I can write F, which is equals to electric force Fe, then magnetic force Fm. Okay, F. Do you know what is electric field equation? Yes, sir, that is Q times E. What is magnetic force equation? That is Q V cross B. Done? Clear now? So this is the equation that you need to remember. Net force. How to get the net force? Done? Easy now? Okay. Let us talk about a special case. A special case. Special case. Okay, special case. Special case means when velocity of particle is perpendicular to my electric field. And that electric field is perpendicular to my magnetic field. Special case. Magnetic field. That means velocity perpendicular to electric field and perpendicular to magnetic field. A very unique and special case. Let us just create a situation that defines this particular thing, right? Look now. If my suppose I will just make this diagram once again. Look now. Then cross means inside the plane. Cross means inside the plane. Okay, that means electric field is from positive to negative. Yes, sir, we know it. And the cross represents magnetic field, which is inside. Now we are placing a charged particle plus Q, and it is going in this way. Okay, velocity. We know that two forces are present here now. One is magnetic force. The magnetic force is in upward direction, Fm. One is electric force, that is downwards. Downwards, right? Suppose, look, we know one thing that, sir, that there will be a deviation. You can see now. Look, sir. Force presence means we know it from the 11th class or from ninth class. If the force is present, either it could deform the shape of object, or it can just simply change the speed of your object, or it can just change the motion direction. The particle is going in a straight line motion. Now, based on the magnitudes of Fe, that means if my magnetic force is big, dominant, then my particle will go upwards. If my electric force is great, so it will go downwards. Now, my aim is, I need this particle to cross this field without deviation. Listen to my words. I want the particle to cross this kind of field without deviation. That means I need this particle to go along this line without any deviation. I guess this path is only possible. I can write it is only possible if net force on this particle is zero. It is only possible now when net force is zero. Yes, sir. If net force acting the particle is zero, I can just guarantee you the particle will go along the line straight. Huh? Okay. So how is it possible? How many forces are being acted here? So two forces. I can write magnetic force Fm, which is equals to Q V cross B. Or I can write it is in magnitude form QVB sine theta. Okay. Second one, what is Fe? Electric force Q times E. Or simply I can write in magnitude terms Q times E. What is theta here? Theta means angle between V and B. You can see here, sir, V and B are perpendicular to each other, so theta is 90 degree. If theta is 90, so Fm came out to be QVB only. Because sine 90 is 1, na? I can write here sine 90 also. Okay, so the answer came out to be QVB only. Okay, so what is net force now? What is net force now here? What is net force now? Sir, if net force needs to be zero, therefore we can write force electric should be equal to force magnetic. Okay, electric force is QE and magnetic is QVB. QQ cancel out. So velocity came out to be E by B. Okay, E by B. Do you know what is the meaning of this simple statement? That means only those charged particle will cross this path. Only those charged particle will cross this path without deviation, whose velocity is equals to the ratio of electric field and magnetic field. Okay, and this topic is known as velocity selector. Velocity selector. Why? Because we know that I need a velocity of 10 meters per second. This velocity I need. Okay. So to get this thing fixed, I need to change the value of E and B. Then I will fix the value of E and B. So here I will get only those particles undeviated, undeflected, whose value will come across only 10 meters per second. So this topic is known as velocity selector. So we can just get one more point from this particular observational. That means if electric field is also present and magnetic field is also present, if both the fields are acting on a charged particle, still it is possible that charged particle will go undeviated on the path. The charged particle will go undeviated. Then we can do one more thing now. What, sir? Look. F net is 0. F net is 0. Yes, sir, we know that. So what is F in vector forms? Is it QE? Yes, sir. Plus Q V cross B. Yes, sir. Can I write now QE is equals to Q minus Q V cross B? Q cancel out. Therefore, my electric field is equals to minus V cross B. Or I can write my electric field direction is equals to B cross V. So by this simple equation, we can conclude that, yes, only if, yes, we can conclude that how we can get the direction of my electric field. It is B cross V. It is B cross V. Take your right hand, okay? Place your fingers in the direction of B. B is inside. Curl your fingers in the direction of velocity. Velocity is here now. Look. So thumb comes downwards and downwards is my electric field. Yes, beta. Yes. Only when velocity is perpendicular to electric field and electric field is perpendicular to magnetic field. In this particular scenario, when the net force is zero, so my particle will go undeviated throughout the path. Done? Based on this particular thing that we just discussed it now, I will just tell you one simple question, a conceptual question, a very conceptual question that simply indicates where you can apply this particular concept. Look now, if suppose we are having a numerical electric field and magnetic field, electric field and magnetic field both are present, what we need to discuss, my aim is particle, I need my particle needs to cross the field without deviation or straight line. Now I will give some options. Option number first. Am I lagging? One second. Am I lagging? Now? I guess I'm lagging, right? So first option, if my electric field is 0 and my magnetic field is 0, in this case, is it possible? Second, if electric field is not 0 but magnetic field is 0, in this case, third case, if my electric field is not 0 and my magnetic field electric field is 0, magnetic field is not 0, okay. Fourth case, both are present. So we are having 4 options. We need to tick one correct one, okay, or there should be a more than one correct option also. Okay, sir. Look, let us discuss one by one. If electric field and magnetic field both are not present, so I guess my force net is 0. If net force is 0, so yes, it is possible a straight line. Second, magnetic force is 0 but electric is not. Let us suppose my electric field is in this way. Suppose now, if this represent my electric field and my charged particle is plus and it is going in this way, velocity. Okay, so what will happen? Particle will go in a straight line, but due to this force, speed will increase. Speed increases. Now this one, electric field is 0, but magnetic is not 0. Suppose my magnetic force is in this way. My field, okay. particle is going in this way. So force is equals to Q V B sine theta. I guess you can write here, theta came out to be 0 and sine 0 is 0. So my force is 0. Yes, sir. In this also case, my particle will go straight line. Yes, this is also possible, possible. Now this one is possible. In what case? A velocity selector, na? In a velocity selector case, we now discussed it, na? If electric field is perpendicular to magnetic field and perpendicular to velocity, in this case, my particle will cross the kind of field without deviating, without deviation. Yes, these are possible. So in this way, we can use it. Done? If let us suppose we will increase one thing. Sir, last numerical is stand, but my velocity needs to be constant. That means speed. My speed needs to be constant. Or velocity, there is no issue. Option, same. E0, B0. Second, E not 0, but B0. Third, E0, B not equals to 0. Fourth, E not equals to 0, B not equals to 0. We know that here net force is 0. Net force is 0, so V constant. Okay. This thing we conclude now, na? Which velocity selector case? Velocity selector. That means E perpendicular to V, V perpendicular to B. Yes. Possible. This one. If B is not 0, but E is 0. Okay. We know that work done by magnetic field is 0. So velocity constant. Okay. But here you can see electric field is not 0. So in this case, velocity is not constant. Done. So in uppercase, all these cases are correct. This one. All cases correct. But in second one, only first, third, fourth are correct. Easy or super easy? Easy or super easy? Again, 4 and 1. So you are having issue with 4 option and 1 option? Okay. Now, what had we studied in last classes? I guess we studied if theta is a 90 degree, so due to which what will happen? There will be a circular motion. I guess we are done with this case. Now. And wire R came out to be mv by qb, p by qb, 2me by qb root, or 2mqv root divided by qb. So we had discussed this can, right? The motion we done this with, right? And also time period, na? That is 2 pi m by qb. Okay. Case number second, that is theta is 0 degree. If theta is 0, so f equals to qvb sine theta. And I can write it is qvb sine 0 degree. Sine 0 is 0, so my force is 0. If force is 0, particle will be straight line motion. This one is most important. That means you will get 90% numerical based on this particular one. Okay. Now third one. I guess in last class we discussed we are having three cases that we need to study: 90, 0, and any angle. Okay, any angle. Case number third. Case number third. Theta is any angle. Any angle, beta. Any angle. So I will write here, sir, path will be helical. Path is helical. How, sir? Look, beta. Suppose this particular thing is my magnetic field. Suppose, no? Okay. Now we are projecting my particle towards V and my angle is theta. From elements, we know that if something is in middle of our angles, so we can just break down these things into component formulas: V cos theta and V sin theta. Okay. Now, one second. This is V cos theta. Okay. This is B. Do you know what is the angle between V cos theta and B? I can 0 degree. Okay. What is the angle between V sin theta and B? 90 degree. And you can see here. No? If 90 degree circular motion, that simply indicates this particular component of velocity will try to keep this particle in a circular motion. It will try to keep it like this in a circular motion. But we have one more particle, that is V cos. We have one more velocity component, V cos theta. So look now, one component V sin theta, one component V cos theta. V sin theta tries to keep your particle in circular motion like this, right? But V cos theta will try to just drag it towards the magnetic force B. So it will be like this, and this will push it. Now look, push it, right? It will behave like a spiral. It will behave like a, one second. I guess there is a network issue now. One second, beta. Lot of internet issues going on right now. What can I do? Yeah, it's good now. Look now, just see my hand, right? So this is V sin theta. Now V cos theta will try to push it. Now look, push it. So it will behave like a spiral. So this will try to keep in a circular motion. This will place a straight line motion. Summation of circular and straight line known as helical. So the path will behave like this. So the path will behave like this. One second. It is not good. One second. But am I lagging? Why my network is lagging? One second. One second, beta. I don't know what happens with it. Still. Okay, due to the weather condition, I guess, right? Sometimes, no. So this path is helical path. This path means helical path. Okay. So if you are having any angle, so the path that you will get, it is helical path. And why you will get helical path? because due to these two components, v sine theta, we will get circular path, v cos theta, we will get a straight line. So the summation of both the effective will give us helical path. Look, this distance between two circular motion known as what? Pitch. Pitch means distance only. Okay, somebody will ask you, but what is pitch in helical path? In helical path, pitch means the distance covered by the particle while going into circular motion. While going into circular motion, that particular distance is known as pitch. Okay, done? Done now? So what is pitch? You can see now. Pitch is distance. Distance is equals to uh, speed into time. What is speed? What is speed? Or which one is speed? Can we just write v cos theta as speed or v sin theta? I guess, sir, the speed parameter is v sin theta only now. So v cos theta. Instead of speed, I can write v cos theta. Then time. What is time? Is it 2 pi m by qb? Therefore, I can write pitch came out to be v cos theta 2 pi m qb. This is my pitch. If somebody will ask you what is radius, how to define radius? I guess radius is mv by qb, na? mv by qb. But which v? Which v is responsible for circular motion? I guess v sin theta. I can write here v sin theta only. Done? Easy or super easy? Easy or super easy? Let me know in the comment box. Is it easy or super easy? Huh? Easy or super easy, no? Super easy. Okay. I think you're getting something from my class, right? Something, no? If let's suppose you're getting 10% from class, that is more than enough. Okay. I'm just making all the content now very approachable. That means I'm not teaching you in a bored manner. Okay, I'm just giving you to the point question, to the point. I'm not creating some sort of the pile of things. I'm giving simple illustration of any numerical, simple illustration of any concept. Okay, but I am giving you the 100% material, 100% concept, 100% your quality things. Okay, but to the point. Okay, now let us start the next topic. Okay, after attending class, you can just go to your module or NCRT or any book that you like, any book, any module throughout any institution in India, any DPPs, right? You will find that quality that I'm just giving to you here. Okay, it is not something that I'm not just teaching you some stuff. No, I am giving you the 100%, 100%. You can do one thing. You can just read the line of NCRT one by line, one to one, one to one. Good, better. I have a lot of classes from morning to the night. Na. Some I don't have that much of time. Na. But definitely, I'm just trying to just create something very great for your future also, right? And definitely, I'm just working on it, but that will take some time. Okay, to be honest with you, that will take some time. Okay, because in this month, we are in August, right? We are in August. In this month, we will complete magnetic effect. We will complete this thing. We will complete EMI. we will complete AC, we will complete EM waves. Done. And I guess optics also. These things we will complete in August. Okay. I will complete these chapters in this particular month. I will try to complete more. Okay. Look, it will take hardly 2 lectures more, 2 lectures. Hardly. That means tomorrow, Saturday, one Monday, or maximum 3 lectures. Then it will take three lectures or 4 lectures. Also 3 lectures or 4 lectures. One lecture. It will take, I guess, 10 lectures. Okay. Then we are having modern. Modern will take 1 week. Then we have semiconductor, right? That will take 4 days. This is my time, I guess. So in which I will just complete mid 15 September or before. I will write here before 15 September, complete syllabus. We will complete our whole syllabus. If everything goes smoothly, great, right? So before 15 September, we will complete whole 12 syllabus, whole 12. Then for 1 week, we didn't anything. Then we will start numericals. Okay, 100, 200, 500,000 numericals. That series, NCRT series, and 11th also, foundation also, 9th, 10th also, right? Okay, now let's jump to the next topic. Next topic is force on a current carrying conductor. Current carrying conductor placed in external magnetic field. Magnetic field. Then that means suppose we're having a magnetic field. Look, and this magnetic field is external that we have given. No? It is not created by any current. It is externally built by any external source. It is B, no? Okay. We are having a rod, current carrying conductor. If this is my current carrying conductor, look now. Current carrying conductor. Okay. If the length of this current carrying conductor is L, if area of cross section is A, done. So we know one thing, that in this conductor we are having free charge particles. Suppose this is my free charge particle plus Q charge particle. Okay. Let's suppose current is going in this way. Suppose, which indicates my charge particle is getting drifted in this way. It is positive, it is not negative. Don't get confused. If positive charge is going in this way, that means current is going in this way. If negative is going in this way, so my current will go in this way. Right? Now, suppose if charge particle positive is given rightwards, right? So take your right hand, V cross B, V cross B. Your thumb is getting upwards. That means the force that this magnetic field is exerting on the particle is upwards. It is my force F. This is a force F. And this F is equals to I current L cross B. L cross B. Okay, what is I? Sir, I is current. What is L? L is displacement vector. Displacement vector of your wire. What is B? B is magnetic field. Now let us do the derivation of it. derivational thing. Derivation. How to get it? Look, I guess if current is flowing, I guess current is only flowing when free charge particles are moving, right? So if 1 million charged particles are moving, we are saying that there is a current. But to get the current now, we had charged particle. Okay, sir. So can I do one thing? I will just zoom. It is a zoom version of your conductor. I just zoom it. Zoom, no? Big. I will take here charged particle, a small area. I will take this area. This area. If you need to write it is volume. What is volume of this area? If this length is dl, what is the volume of this area? Volume is length into area. Length is dl, area is a. Is volume dl a? Yes, sir, it is dl a. Now, so what is total amount of? I can write total number of charge in this particular volume. Is it n a dl? N means number of charged particles per unit volume into the volume of this particular band. Done. So look here, positive, Vd is in this direction, force is here. So what is force? Is it Q V cross B? Yes, sir. What is Q? I will take as a E. Done. What is V? Is it drift velocity Vd? B is B. Look here now. Force on wire equals to number of charged particles, that means N A dl, then force on one charged particle, is it E V, is it E, and what we have Vd cross B. Okay, sir. Look, what is current? Current is NEAVD. NEAVD. Instead of this thing, I will write current I. Then I will write dl cross B, force. Now, if we take the whole length, that is L, so can I write now force is equals to I, L cross B. Yes, number density. Look now, force on a single charge particle, Q V cross B. Force due to the external magnetic field on the current carrying wire. That means I, L cross B. I is current, L is the displacement vector, and B is magnetic field. So, what is displacement vector? Oh, let's suppose what is, I can write it I, L, B sin theta also, no? What is theta? Angle between L and B with theta. We know it, no? I'm not taking that much time to understand this thing, right? So let us suppose we are having a wire. Okay. This is my wire. And it is present in a magnetic field this much, point A and point B with I. Now, for numerical purposes, so I will take a displacement vector B A I. So instead of this curved wire, I will take a straight line wire. That means L. This is L. AB. It is displacement. One more thing. If my wire is in this shape, A, B, radius is R, current is I flowing, I can write this one as, simply I will just change it to this one with length 2R, it's A and B. Displacement across A and B, is it 2R? 2R. Current flowing is same, that is same from A to B. This is your displacement vector. This is your displacement vector. Done? Yes, it is force on the whole wire. It is, we are not specifying a charged particle. Obviously, no, we are having, look, we are having 1,000 charged particles. So what we can do? We will calculate force on one charged particle multiplied by the 1,000. So this term is known as force on the whole wire. Let us do some numericals then. Okay, look now. Okay, one numerical. Radius is r, current is I, AB. Magnetic field is inside like this. So I can write F equals to I L cross B, or it is I L B sine theta. Okay, look, take your right hand, take your right hand. Then is it A is R and R? Okay, that means I can write it in this way. B A I 2R. Current, take your hand. Okay, so B is inside. B is inside. Yes. Current is in this way. Length is in this way. So you can write theta is 90 degree. Theta came out to be 90 degree. If theta is 90, so sine 90 is 1. So F equals to ILB sine 90. F is F, I is I, L is 2R, sine B is B, sine 90 is 1. So F came out to be 2IRB. This is the value. Yes, ILB sine 3. Yes, definitely. Okay, let's do one more numerical. One more numerical. Same but different. A point, B point. Radius R, current flowing I, and magnetic field is in this way. Magnetic field. Okay, what is F? ILB sine theta. Look, beta. This is your current. Current now. Current. B is in this way. Current is also in this way. So what is theta? 0 degree. So I can write F equals to ILB sine 0, and sine 0 is 0. My F came out to be 0. F is 0. Okay. Take your right hand and you will get the answer. A cross B. One more numerical. A 3 ampere. B 8 meter. 6 meter. Done. Magnetic field inside it is 10 Tesla. Find force. For force, just make a displacement now. So this line is displacement. Once again, is this line a displacement? Yes, this line is displacement. Okay, look, this one is 8, this one is 6. So I can write it is 8 square plus 6 square root, 64 plus 36 root, 100 root, that is 10 meter. So displacement came out to be 10 meter. B is 10. Then current is 3. Then theta is 90 degree. So what is F? Is it ILB sine 90? I is 3, L is 10, B is how much? B is also 10. Sine 90 is 1. I guess my answer came out with 300 Newton. Is it 300 Newton? Easy or super easy? Is this easy or super easy? Huh? Okay. One thing, if let us suppose if displacement is zero, so what about the force? I guess force is also zero. If displacement is zero, force is zero. Okay. Suppose we are having a shape like this, a closed shape. Current I is flowing and it is placed in a magnetic field B. So could you just tell me what is the force on this loop? What is the force on this loop? Sir, you can see in the circular motion, if we start from this point, we are coming back to this point. So my L is zero, so F is zero. Okay. So what about this one? What about this one? B is answered. Also, sir, shame it is closed, no? It is a closed loop. So L is zero, so F is zero. What about this one? Same, closed loop, L is zero, F is zero. Okay, one more. Look, magnetic field, same, L is zero, F is zero. Done? Done now? Let us do one more thing. Let us just find tension from 11th class. Suppose we are having a irregular shape thing, right? Current I is flowing in this way. Look now. What will happen? What will happen if magnetic field is insert? B. Let's take this small element, this element. Current is in this way. It is current. B is inside. B. B is inside. So where will it force? I cross B. I length is upwards, no? No, it will, let's suppose current is not in this way. Suppose current is in this way. Suppose current. Okay. I cross B, it is I, B. 1 second, beta. Cross B is here. So if current is going this way, magnetic field inside. Yeah, it will be in this way now. So force will be in this way. Same, let's take this element. Current is in this way. My current. I cross B, force is upwards. Same force will be here. Force will be here. Now this shape gets converted into this perfectly this shape. Okay. Current I is flowing. Current I is flowing. Then, so what we know that now, sir, force net is zero. Why, sir? Because L is zero. If somebody will ask you find tension, find tension. Okay, this word you need to highlight. Find tension. This one. Sir, how to find tension now? Let us just cut the whole thing into two parts. Let us cut this one into two parts. Okay. If we cut it two parts, so we will get this loop only. Current I is flowing. A point, B point. If a radius is R, so I can write it in this way. If it is A, B, I, this length is 2R. Done? So on this one, my force is upwards. This is my force. Done, no? So what is force? Force is equals to ILB sine theta. Theta is 90 degrees. So I can write F equals to ILB only. L is 2R, 2RB. First equation. First equation now. Second equation. You can write Tension will be here. Tension T, tension T. Done. So it is T, T. And force is upwards. Can I write now 2T equals to force? 2T. Force is equals to 2 RBI. 2 to cancel out. Tension came out to be RBI. Note down this one. How to find tension. Right? How to find tension. And this thing was asked in your IIT, right? How to find tension. And the answer is RBI, Reserve Bank of India. RBI, na shortcut way. RBI. This is how you need to do this calculation so that you will get your tension also. A different approach. Okay. One more thing. Most important thing. Most important. You will write here. So it is most important. Most important. That means force between parallel current carrying wire. Current carrying wire. Okay. If we are having a wire coming from infinite goes towards infinite with current I1. Now D distance apart. One more wire. Okay. With current I2 in same direction. So what we need to find out? Find force on second due to first. Per unit length, length means D or length. Aim is force per unit length. Look now. Take your right hand. Take right hand. Current is upwards, upwards. Now stretch your fingers towards I2. So that means my magnetic field will be inverse. What is this one? Cross. Is it magnetic field? Is it magnetic field due to current first or current wire first? Yes, sir. Look here now. Sir, current is flowing upwards. Current is flowing upwards. Okay. Take your right hand. Current is flowing upwards. Done. Upwards. Take your right hand upwards. Magnetic field is inwards. Take your curve your fingers inwards. What is thumb? Thumb is left side. Na? So my force will be here. Same direction current. This force is attractive. This force is attractive. So how to write force? Sir, force on 2 due to 1 is equals to B I L sine theta. B, which B? Sir, this B. Is it due to 1? Yes, sir. Current, is it current of second? L. What is L? L is D, I guess. Okay. What is 9 sine theta? Theta is 90. Why, sir? You can write current is upwards, it is inwards, so sine is 90 degree. So can I write now F came out to be, is it B1, I2, L? What is B1? What is B1? Is it magnetic field? Is it nu naught I1 divided by, is it 2 pi d? Yes, sir, 2 pi d. F equals to nu naught I1 I2 L divided by 2 pi d. So this particular equation means force on the whole wire. But I want per unit length, so I will take divide with L. So it came out to be nu naught I1 I2 divided by 2 pi d. Nu naught I1 I2 2 pi d. This means force per unit length. Is it force per unit length? This is net force. Whole wire. Same direction, attractive force. Same direction, attractive force. Done. Let us do two numericals. Then today's class. Goodbye. Okay. Look now. Look now. Look now. Look now. Look now. We are having a wire. R wire. Current is flowing 20 ampere. One more wire. Q. Current flowing downwards 10 ampere. One more wire. This one. Current flowing 30 ampere. This is P wire. Find force on Q. Find force on Q due to R and P. R and P. If this distance is 2 centimeter, this one is 10 centimeter, and length of R equals to Q equals to P equals to 10 centimeter. Okay, sir, no issue. So look now. If current is upwards, and suppose if we talk about B, I guess B is not given. Let's about okay. If current is upwards, okay, take your right hand upwards. Now curl your fingers towards the point where we need to find it. Done, no? Or you can do one thing. Look now. Sir, opposite direction current. That means force is repulsive. It is F1. So what is F1 now? F1 is nu naught I1 I2 divided by 2 pi d into L. Nu naught is 4 pi into 10 to the power minus 7. I1 is 30 ampere. I2 is 10 ampere. Length is 10 centimeter. 10 centimeter. Whole divided by 2 pi d. D is 10 centimeter. This thing cancel out. 2 pi, 2 cancel out. Look now. 2 3s are 6. I can write 6 into minus 7 plus 2 minus 5, 10 to power minus 5 Newton. Now look, current in opposite direction force is repulsive if it F2. So was it F2 now? Same, nu naught I1 I2 L divided by 2 pi d. Nu naught is 4 pi into 10 to the power minus 7. I1 is 10 ampere. I2 is 20 ampere. L is 10 centimeter. Whole divided by 2 pi. D is 2 centimeter. Cancel out 2 to 4. 4 cancel out. Pi cancel out. So it is 20. So I get 20 now. Is 20 10 to power minus 7 Newton. Sorry, minus 5 Newton. So what is, okay, look, both forces are opposite to each other. Which one is more, F1 or F2? Sir, F2. So I can write F net equals to F2 minus F1. F2 is 20 into 10 to power minus 5 minus 6 10 to power minus 5. I guess answer is 14 10 to power minus 5 Newton. This one is my answer. Prachi beta, hello. This one is my answer. Easy or super easy? Easy or super easy? Huh? Easy or super easy? Or any confusion? Okay. One more numerical. Different one now. Look here. Current I1 is flowing in this one. One more wire is this one with length L. And this wire is a distance apart from the line of current. Okay. And in this one, current I2 is flowing. Find force. You cannot write this one now. You cannot write this one now. Do you know why? Look, beta. Look. What is B? Is it nu naught I divided by 2 pi d? Yes, sir. That means magnetic field is depending on mu naught, current, 2 pi and d. It is depending on distance. Look here, distance is different. Here difference is distant. Look here. On every point on this line L, my distance is different. If D is different, therefore B is different. If B is different, so I cannot use this equation now. Why? Two different. Look now, if distance is different now, we cannot use a constant magnetic field definition here. Yes. Why? Because magnetic field is variable now. Right? So I can write now magnetic field is variable now. Sir, how we can do it now? We know it from the very previous class now. If something is like this, so we need to one thing. 1 second, beta. 1 second. One second. Struck. Okay. So how we can do it? I will take a small element length with dx distance apart from my this one. Here force will be small df. It will be nu naught I1 divided by 2 pi x. Right? I, look what we have. F equals to BIL sine theta. So B equals to nu naught I1, that is 2 pi x. Current I is I, that means I2. Is it I2? L, what is L? L is dx. Then sine 90 degree. So df came out to be nu naught I1 I2 2 pi x dx. But I want the whole f from A. From this A to this one. Is it A plus L? Yes, sir. So A to A plus L. We had done this calculation in our electrostatic first class also. So F came out to be nu naught constant, I1, I2 constant, 2 pi constant, then integration of 1 by x dx. A plus L. So integration of 1 by x is ln of x. Natural log of x. Nu naught I1, I2, 2 pi ln of x. Upper limit is A plus L, lower is A. So I can write it as nu naught I1, I2, 2 pi ln of A by plus L divided by A. This is my answer. Take a minute. Okay, just try to understand this derivation. If you find any doubt, you can just let me know. You can just let me know. And I will tell you the usage of this particular derivation now. Last 5 minutes of the class, last 5 minutes of today's class, last 5 minutes. Okay. If you have any doubt or anything like that, you can just let me know. Okay, let's do one numerical. Why you can hang 1 second. Look better. Current I1 is flowing. Here we are having a loop. It's my loop. Okay. With this one is also A square, right? This one is also A. Or you can write B and B, no issue. B and B. And this length is A. We cannot write if B is constant, then force is 0. Here you can see B is not constant. Here you can see B is not constant. Okay, we need to find F on this wire. F on this wire. Then, so how to get F? Look better. This particular point and this one equal distance. This one equal distance. Each and every point on this one will have a sibling on this one, na? Okay. Look now, magnetic field is inside. We know that. Current magnetic field. So on this one, force is upwards. On this one, force is downwards. On this one, force is in this way. F1 force is in this way. So this one get cancelled out. Why, sir? Because force will be same. Equal distance, no? Okay. What is F1 now? F1. Is it nu naught I1 I2 divided by, is it 2 pi A? 2 pi A, then length. Length is here B. Nu naught I1 I2 divided by 2 pi. A plus B, here we are having cross B. Which one is more? Sir, obviously, na, F1 is more than F2. So I can write F net equals to F1 minus F2. So I can write now nu naught I1 I2. I will take common in 2 by also. So we are left with B by A, then minus B divided by A plus B. So is it nu naught I1 I2 divided by 2 pi? Is it I will take B also common. B common. It is A plus B minus A divided by A and A plus B. Cancel out. Therefore, my answer came out to be nu naught I1 I2 B divided by 2 pi. Is it A plus B? It is B square. So this one is my answer. And by this numerical, we just conclude today's class. I hope that you got something an iota equal something from my classes. Okay. And if you want to ask me anything, you are most welcome. If not, then bye beta. We are done with today's class. At the end of the class of the after the lecture series of this chapter, you will get these notes. If you are not getting enough time to just write these notes, you will get the whole note in my Telegram group. Okay, and the description part of Telegram is given in the description part of channel also. You can write Shukur Sir Physics. So I thank you, beta. Thank you for today. Thank you, beta ji. Thank you. Bye, beta.